that light off. Okay, so we will learn how to write formulas from the programs. So I think this one we did. So if I give you those name of the elements, and you can write the formula for the compound we produce. One type of compound is ionic compound. Ionic compound has ion in it, so therefore you can write out the formula with name and with ratios. So this problem we did, and we get the final result is Al2 and O3, and we said we get this 2 on the Al from this number 2 from the oxygen, and we get a 3 for O from the number from Al. So we do some kind of like a swapping switch, and once you switch, and you will be able to continue. And so after you switch, you get those numbers, maybe 23, maybe 22, and then you check it and see if you can simplify. So those kind of formula you get are the so-called empirical formula. Okay? So you want to get the empirical formula. The empirical formula is synchronous, I mean, it has a number, has a synchronous ratio. Okay? So therefore, after you switch, you get the numbers. Make sure you check it. If you can simplify, you simplify. And simplify until you get the synchronous ratio of integers. You don't want to get the decimal numbers. Okay? So in this example, that is the synchronous ratio. Okay? Between 3 and 2, that's a synchronous one. You don't want to have 1 and 1.5. Not like Al1 and O 1.5. You don't want those ratios. Right. I think the next example is similar. You want to write an empirical formula for the ionic compound produced between calcium and oxygen. Follow these 5 steps. Okay? So first step, you want to get the simple and the charge, simple and charge for the metal cation. Usually the cation comes from metal. Okay? So I give you 2 elements. You identify calcium is metal, oxygen is non-metal, and then you will see the symbol for calcium is Ca, and so then you predicting what is the charge for some of those common metal ions, metal cations. Okay? So calcium is in group 2A, so therefore this will be 2 plus. We get these 2 information by our study. So we know metal produces the cation, so therefore we have a plus. And how much plus? 1 plus, 2 plus, 3 plus, depend on the A group number. If the A group number is 2 in this example, and you see this, I write this 2A, that means I get this information from the periodic table, so therefore we have 2 plus. And so then we go to step 2. We want to write the simple and the charge for the anion. Anion, especially those monoatomic anion, will come from those nonmetals. So in this example, the nonmetal is oxygen. Oxygen, the chemical symbol is O. So therefore, you first write that up. And so then you know this will produce the anion, negative ion. And then you see negative how much? Negative 1, negative 2, negative 3. Right. For the negative number, we do the prediction, use the group A number minus 8. So we know oxygen is 6A, so therefore we take 6 minus 8 equals -2, and you write up in the charge like 2 negative. Right, so once we have these 2 ions right up, and you always write the cation first. The positive ion you want to write first. Okay? And then you do the switching. Okay? So what you do, you will take the number for the charge from one ion, use that number as the subscript for the other ion, for the counter ion. Okay? So we will take these 2 and put it here for calcium. Okay? And we'll take the other 2, and in this number again they are the same, so therefore it's okay. So you get 2 and 2, even though they both come from different place. Right, so therefore you will write C2 and O2. After you switch, you don't have to repeating those chart informations. In the final formula for the ionic compound, we call that empirical formula or molecular formula, you don't show the charge. You usually don't show the charge. Because that is not necessary to show the charge. We know what is the charge. Right. So then you are going to simplify the numbers from switch. Right. So in this example, the 2 numbers from switch is these 2 and these 2. Okay. So therefore, this right now not a simple ratio. Okay. And you can reduce into C and O. And that's simple like that. Right, so let's do some practice. So if I give you 2 elements in this CRE, and one is lithium, the other one is nitrogen, follow the 5 steps. So let me see what you get. Right? Follow the 5 steps. This will be a very easy, simple question. Okay, anybody ready to tell me the answer? D. D? D. D, right? Yeah. Everybody agree? D? Yeah. Good. So that's, you get lithium 1A and nitrogen 5A. Lithium metal, so therefore is lithium metal, so therefore is Li1 plus. Nitrogen is non-metal and is 3 negative. Understand? So you take the 3, switch on to lithium. Here is 1 plus, you take 1, switch on the N, and you get Li3N. Right? So 1 is usually omit. You get 1, you don't have to write 1. Right? So this equals Li3N. The same. And I don't want to reduce anymore because that's already the simple ratio. Alright, so do another practice. So here I even use the table. So this table here show you those ions commonly you will see them, and you can predict their charge according to the location on the table. Okay, so who is ready to tell me the answer? A. A. Everybody agree? A. Mm-hmm. Good. So that's again potassium is K, and the group number is 1A, and oxygen is O, group number 6A. So when you predicting the charge for the metal cations, you just use the group number. So therefore, 1A here tells us K will be 1 plus. And 6A here tells us you take 6 minus 8 equals -2. So therefore, O will be 2 negative. Now you do the switch again, right? So I take this 2 and switch on to plus n, and take this 1, switch on to O, and I get K2 and O1. This is the same as K2 and O. Right. So now we are going to talk about namings. So we did a simple practice about how to write a formula for those ionic compounds we produce, use metal and non-metals. That is the most common, even though it's the simple problems, but it's the most common. So then the naming, we're going to talk about naming 3 types of compound here. And in this chapter, so then there are some compound has a common name. So what we emphasize here is the so-called systematic names. So we don't worry too much about those common names. So these 3 types of compound is first is ionic compound, and the second type is a binary molecular compound, and then the number 3 is acid.
What slide is this one?
Huh? I add one slide. You don't have this one. This is, yeah. Okay, so remember we have these 3 types of compound. We are going to study their naming, the systematic naming, and each type has a larger pattern. Then within the larger pattern, there are some small details. So let's first study the first type. Let's study how to naming the ionic compound. And then you will see the naming pattern for the ionic compound. Alright, so the first one is naming ionic compound. The naming pattern is like this. You will have the name for the cation, then space, then name for the anion. So that will be the larger pattern for naming the ionic compound. Example is NaCl, and I call this very common sodium for Na. Then space chloride. See, this is the pattern. Right? So you get the name for the cation, then space, and then name for the anion. So this is the first type of compound we're going to learn in this chapter. And so then what is the rule for naming those cations, anions? If you know that, just follow this pattern and get the name for the cation first, space, and then the name of the anion, then you get the name right. So therefore, to solve the problem, or to get the right name, we have to study those naming for the cation and naming for the anion. So then, for the cation name, there are 3 possibilities. for the cation name. Either the name of the metal element. That will be the simplest possibility. Like in this example, sodium, nothing else. Because this Na is the metal element of sodium. And you call sodium element is sodium, you call this Na this ion is also sodium. Right. The second possibility is metal name with parentheses with Roman numeral. Okay. So I'll give you one example of that. Is that FeCl3. If I tell you there is one compound FeCl3, you want to name this. You know this Fe is a metal produces cation, and Fe's name is Rn. But in this example, you not simply use this element name Rn. You use Rn then with the parentheses with Roman numeral, and then this Cl still the same pattern. So therefore we call that Rn3 chloride. So now what metal you name in the first pattern? What metal you name in the second pattern? We are going to study that in this chapter. And you just memorize, we have 14 metals in this chapter, and in general more than 14, maybe 17 or 18, depending on the book, but in this chapter, I just want you to memorize there are 14 common metals use the first pattern, which means you don't use Roman numeral, just use the metal name, and that's enough. 14 of that. If you know that 14 metals has this pattern, then all the other metals will have this pattern. Is that simple or not?
Did you already tell us what the 14 were?
Yeah, I'm going to tell you the 14. Well, I'll be nice to tell you 14. So the 14 have, so this first pattern you will have 14 those metals whose ion's name is simply the same as the metal name. Okay? What are the 14? You will see 5 from that group 1A, and the other 5 filter, I mean the same as above, from group 2A, and then 1 from group 3A, and then 3 from transition metals. Right? So then you can see that will add up 14. So we use a group to make our study a little easier. Okay? So what is in group 1A? What is in group 2A? You can memorize that relatively easy. Right? Who is in group 1A?
Hydrogen?
Metals.
Metals? Oh.
Yeah. Yeah, so you will see that the first one is Li, right? Li, and Li produces what plus? 1 plus, therefore it has 1 plus. And what is the name of this? It's simply as the metal name. Okay? If you name this ion by itself, you probably just say lithium ion. But once you put them in those kind of compound, when you name the compound, you don't have to have the word ion in it. Alright, so then the second one will be
Sodium.
Na plus, and so then similar, so will be sodium ion. So then the other one will be what it was?
Potassium.
K and potassium ion, and then what else? Rubidium. Rubidium ion, and I have the CS, right, which is cesium ion. So that is the 5 from group 1A. And so then the other 5 from group 2A. And the first one with the BE 2 plus, because they are in group 2A, they operate 2 plus. And similar pattern, so you don't have to name anything else, just call that a barium. Okay? You don't have to use Roman numeral or parentheses because barium is always 2 plus. And next one will be what? Mg 2 plus. Again, if you name those ion by themselves, you already have that word ion. Alright, then what we have next is C2 plus, is calcium ion. And then we have that SR2 plus, and that will be our what? Strontium ion. And then last one will be our Ca2 plus, and that will be our barium ion. Right, so you can see this 10, 3A, the most common one 3A will be that Al3 plus, and what do you call that? Aluminum ion, even though you can have a Ga under aluminum or below aluminum will be Ga gallium, also 3 plus. And under Ga will be the In indium, also 3 plus, but not that commonly used. So let's simplify. We just memorize the 14, right? And then the other 3 from transition metals. One is Sc3 plus, and you call that scandium ion. And then you have that Zn2 plus, and you call that zinc ion. Right. So then let's write here the other. So these are the 3. I will just write here. Keep them consistent. And so the other one will be the Ag1 plus. Ag1 plus, and this one called the silver. So then, if you know your metal is belong to this 14, right? Belong to this 14, and okay, so let me just say these are the 14 here. If you know your metal is one of those 14 metals, and then your name for those ions will be simply the element name. Very simple, nothing else. Then use elimination. If you have a metal like what I used before, that FeCl3, you want to name this compound, and this compound is an ionic compound, even though in later chapters this may be not always true. For some of the compounds we see here is ionic bond or ionic compound, but in general we are still true. So we just see whenever we have metal plus non-metal, no matter what we study later on in the other chapters, we call those compound produced between a metal and non-metal ionic. And then you name those compound, just name the cation, name the anion. So name the cation, we have that 3 patterns. Okay? And I will summarize later on in the table on that. So one pattern is use the metal name themselves. The other pattern is metal name with Roman numeral. Okay? So those are the first pattern, which means if you have those metals in your compound, like sodium chloride, NaCl, just simply sodium chloride. If you have metals that are not in this list in your compound, you'll name that, and make sure you use metal name and also the Roman numeral, and so that will be the total name for the cation. Okay? So then the pattern number 3 is those kind of ions that is not like come from like one metal atom by themselves. maybe a group of metal atoms, like not common. Usually you will see those so-called polyatomic ion. Okay? Polyatomic ion, their name is kind of common name, so you just memorize those names. And that are 3 patterns for the cations. You can see I have here already mentioned 2 patterns. Okay? So 14, then you right here. So we have 14 of these. Simply use a metal name. So then just use elimination. If your metal is not in this 14, you use the second pattern. And then sometimes your cation is not from metal. It's a so-called polyatomic cation. Then you just use their names. One common example of a cation that is polyatomic, you can use a lot in this chapter, and we also talked about that last week, is NH4 1+. I think a lot of you already know this, the so-called ammonium ion. Any questions? Okay. The pattern for the anion, we see there's like basically 2 patterns, but actually there will be 3 patterns according to the ending. Okay? But according to how many atoms in there, in the anion, we have 2 patterns. One is so-called monatomic, which means those anions has only 1 atom in it. So only 1 non-metal atom in it. Then those name is this pattern. You just find the root or the stem of the non-metal element name. You drop the suffix, drop the ending for those names. Okay? Like you always see the examples of chlorine can become chloride. Okay? And this is the pattern. This is one pattern for the anion. Some of those anions that come from like a group of nonmetals, the so-called polyatomic anions. Okay? For those, you just memorize their names. There's a lot of those polyatomic anions. Okay? For example, one is CO3 2 negative, and this is not like a monatomic anion. There are like a few atoms together, 1 carbon 3 O together carry 2 negative, right? And those has the name and have the charge. You have to memorize what are the name, what are the charge. Okay? So for this one, we'll call that carbonate. Alright. So another example, those polyatomic anions is NO3 1 negative. And this one you will call that nitrate. And very similar is NO2 1 negative.
Nitrite.
Very good. So this will call the nitrite. Right. So we list these few more examples because I want to show you there's a different way to see the pattern for the anion. Okay? As I said, according to the ending of the anion, there are 3 different endings. One ending is IDE. And then the other 2 endings is ATE here, ATE carbonate, nitrate. Okay? Or the number 3 ending is ITE, nitrite. So that's memory. So you will be able to memorize them by studying those practice. So I have a practice, naming practice on the iCampus. So make sure you print out and do the practice and you check the answer. On the lecture notes, I also give you one link to a website, and there is more practice. Right. So if I summarize those naming for the ionic compound in this table, and so you don't want to get lost in the forest and just by like a few of those examples. So I think that let's summarize what we learned. Like in this last few slides. We said when we name the ionic compound, we pretty much name the cation and space and name the anion, right? So then we have 3 patterns for the cation and 2 patterns for the anion. I mean, depending on what we have, not depending on what we ending up with. So what are the 2 patterns for naming the cation? What is the first pattern? We talk about the 14.
Just the name.
Just the matter name. Right? Yeah, so that's the first pattern. Let's see a few examples. We have 14 of that. And anyone can give me one example of those metal cations name, just metal name. 14 of that. Huh? What are the 14 of that? Yeah, palladium as a K1 plus. You just call that potassium and Na1 plus. For our sodium. Right. 14 altogether. Right. We have this. Both of these come from group 1A, and we have 5 more from group 2A. Barium, magnesium, calcium, strontium, and barium. So what is the second pattern for the cation? Very good. So you will see the metal name with the parentheses, with the charge, with Roman numeral indicating the charge. Okay. You probably did not see too much of the examples. So I give you some of the examples like Fe2 plus. And you will call this not only Rn, but you have to use the parentheses, Roman numeral, and tell me the 2 plus. Okay? If I give you Cr3 plus, Cr is for chromium. So when you name this Cr3 plus, you will name the metal again, but a little more, you have to use parentheses, Roman numeral to tell me this Cr is 3 plus. And we're going to study like how we figure out if I don't write Cr3 plus is placed like this, if I write something like in the formula like this, how do we figure out Fe is 3 plus or Cr is 3 plus? And think about that. Okay? And so we will study that later. So what is the number 3 pattern for the cation? Very good. Those are the polyatomic cations. Not too many polyatomic cations in this class. So 2 common ones is NH4 1 plus. What do we call this? What do we call the NH4 1 plus? Ammonium. Okay, now one probably you don't know. What do we call this? H3O plus.
Hydroxide?
Yeah, hydroxide. Yeah, very close. This is hydrogen. So these are the 2 common polyatomic cations. Right. What is the 2 patterns we talk about in naming the anions? What is the first pattern?
Non-metal, single, non-atomic.
Yeah, that's
IE in there.
yeah, IDE. Okay, so that means the monatomic anions come from like 1 metal, just take the stem of the non-metal name and plus ID. When we say plus, that means no space, just like everything one word. Okay, I will give you one example. You saw that before. Like if I write CL1 plus, 1 minus, you know that. We call that what? Chloride. And if I write S2 negative, guess what? What do you call this? Sulfide. So you see sulfide. So that's sulfur. Right? And then similarly, what do you call this? What do you call this? N3 negative. Very good. So that's the pattern. Just find the element name and find the stem, and I just drop the suffix and IDE. Right. The second pattern for the anions is those polyatomic anions. Let me give you a few those examples of polyatomic anions. So you already saw that before, like those. Let's see, one example is SO4 2 negative. Anyone know the name of this SO4 2 negative?
Sulfate.
Sulfate. So sulfate. And SO3 2 negative. Yeah, in sulfite, right? Okay, now let me underline those anions. So you see like ATE and ITE and IDE. Right? These are the three typical anions for the anion. Right? So you sometimes you just classify the anion according to how many atoms in it. Sometimes you classify those anions according to what are the anions. The three anions for all those anions. No matter what kind of anion you have, how many atoms in there, and that's all the anions. These are IDE. Okay? All the ATE, all ITE. The PO4. Yeah, you will learn the PO4, like 3 negative. We got the borate. Alright, so these are the few examples of polyatomic anions. So once you do this 3 pattern for the cation, 2 pattern for the anion, and you can do any like those combinations. For example, I have not that one, not this one. I have all those different cations here. I have all those different anions here. You can make a combination of what we did before, and write out the formula by switching simplify, and then you write out the name by simply pile together the name for the cation and the name for the anion. Right? For example, I can take some cation from this group and pair them up like this. Or I can pair up like this, or I can pair up like this. Right? Now let's see the first pair. If I take a K plus and pair up with Cl1 negative, that's very simple possibilities. And you want to get like a couple of things. You want to get the formula, you want to get the name. We learned how to get the formula from previous sections, like from last week. If you know how you have one K plus, 1 plus, and Cl1 negative, and you switch, you will get KCl. So that's what your formula. Okay. Then what will the name for this compound? Platinum chloride. Just take the name for the K plus and take the name for the Cl1 negative together, and that will be the platinum chloride. Right. Now you can also take this group of ions and pair up with any of those here. So if I take like one example. So let's take a liberal TS one, and we take CR3 plus and pair up with SO3 2 negative. Right? So let's get a couple of things. I think the name, you already saw the name. And now let's first get the formula first. Then we will see the name. The name, just already all see the name, just chromium 3 sulfide, right? You will take the name for this CR3 plus, which is chromium 3, and then this SO3 2 negative is sulfide. Therefore, the name for this together, even though we don't have the final formula yet, we call it chromium 3 sulfide. Now, what is the formula for this? Like what we did before. No matter what kind of ion we have, we will take the ion's Chapter number and use that Chapter number as the subscript for the other ion. Right? So I will take this 2, I will take this 2 here, and for this CR. And I will take this 3 here, and for this SO3. Now that's a little problem. But SO3 already has all those numbers, all those letters, kind of like very, very not clear. So what you do is use a parenthesis. So instead of I simply put this 3 here, put this 3 here, I'm going to put a parenthesis, including everything here, in the parenthesis. So therefore, the result is something like this. You still have the CR2, the 2 come from switching from that sulfide, and then this SO3 here, and you put that in the parentheses, then put the subscript 3 here. Now we have a 2 3 here. We have a 3 here inside the parentheses. That comes from this formula. So when you see sulfide, you know it will be SO3. So therefore, you still have this SO3. Right? And this 3 comes from where? Where this 3 come from? From chromium. Okay. Right? So therefore, we have a 2 number coming from a switch. We have this 2 from a switch. You know, see that? Let me write them. This okay, so this SO3 parentheses and 3. Can you see it now? So this, let me move my cursor. Right. So this, remember this SO3 negative sulfide? You can take any of the negative ion, pair up with any of those positive ion, and then you can produce ionic compound. Okay? So if, for example, we will take this CR3 plus and pair up with SO3 2 negative, and we have this. Then we do the switching, so we take this 3 from the CR and we want to put on for the SO3 2 negative. SO3 2 negative are the so-called polyatomic ion. And to make that notation clear, you use parentheses. Parentheses, then 3. Right. And then that will be the same as what we did last week. So you have this 2 from switch, and this 3 from switch, and you cannot simplify anymore. Right? And this will be our final formula. Then what is the name of this CR2 SO3? As we said before, just find out the name for the cation, right? The name for the cation, we call that what? What is the name for this guy? Chromium what? Right. Don't forget the chromium 3, okay? Only those 14 just use the metal name, okay? That's the common problems on the quiz on the exams. Okay? So what time you use the Roman numeral, what time you don't use. Okay, I think you should be able to get it. It's very simple, straightforward, and you just be careful. So this kind of review now, and we know we have that 14 first patterns. That if you know that 14 first patterns, then your cation's name is similar, just the metal name. And I have a different way to memorize. You can either memorize in the group one, what I write here. I can write here, right? So 14 here, right? Any questions? Okay. So probably this is the first memory I want you to memorize for today's lecture. You want to memorize the 14 elements. If you see the 14, make sure you have. If you see the 14 in your formula, never use Roman numeral parentheses. Vice versa. If you see something else not in this list of 14, make sure you just use that parentheses and Roman numeral. Right? So then there are many different ways to memorize. It depends on which way you memorize. Right? So use elimination. If your matter not in that 14, it will be in this table. And this table I will give you a very easy list, only few. Right? And obviously all other metals, even though not here, shall be naming similarly as these few on the table. So then let's review what we learned for the anions. We say anion has two patterns, either like those monatomic anions from like one those nonmetals, just use like the metal steam and drop the suffix and ending with IDE. And then you figure out the chart by taking the group number, A group number minus 8, and then use IDE. Even though some other ion have more than one atom, one type of element in it, also IDE like hydroxide and cyanide, but make sure if those anions come from one nonmetals, and this will be the ID ending too. And here are a few examples, few more examples. You see this fluoride, chloride, oxide, sulfide, and nitride, phosphide, and chloride and silicide. So pretty much the pattern. So those 7A 1 negative, 6A 2 negative, 5A 3 negative, 4A 4 negative. So even though they have different charge, 1 negative for fluoride, 1 negative for chloride, and 2 negative for oxide, 2 negative for sulfide. But one common is no matter the ending, no matter the 2 negative or 1 negative, their ending are the same. So here, so then what you name? Let's see, we have some of those patterns. We have some examples. So one name like those compound, ionic compound that has ion has a cation only one possible charge. What it means, your cation is in this table. So what is the pattern? The pattern inside here is you will take those metal name, nothing else. Okay? And then this part, if we only choose one of those like monatomic anions, then we just take the non-metal root with ID. But in general, you can have those like sulfate, sulfide, carbonate, nitrate, all those possibilities. Now let's see, we have this in one example. Can you see like from the back clear? So we have two type of elements. We have that kerosene and Ca, we have Br, and who is metal? Kerosene, right? So then when you think about the kerosene will be our metal, or we produce our cation, then you think about what would the name? What name that three patterns, either just simply the metal name, or the metal name with Roman numeral, or some of those like polyatomic cation names. But in these examples, you will see what is probably named this Ca. Ca is come from the metal kerosene, right? So now, I think pretty much you will see your metal name will be innate, but whether it will be simply the metal name or metal name with something else, that depends on what is our metal. So we call that kerosene, or possibility is kerosene and something like Roman numeral 2 or 3. Which one should we use? Why the first one?
It's 1 and 14.
Very good. That's what I emphasize here today. You want to memorize the 14. If your metal is not 14, just use metal name. Okay? Therefore, don't use this. If you use this, that's a common exam question. It will give you some of those wrong answers. Right. So that's what is the name of that for that part, for that element. Okay? And then we have the other part. We have BR, and I have 2. Okay? Well, so shall we worry about convey the information or tell me the information about that too, or shall we simply name according to like what kind of anon we have? You don't have to worry about that too. Okay? For those kind of compound, for the ionic compound, don't worry about the 2 because the 2 you can figure out from the charge of that Ca. Okay? And then what we name that will be simply what? Yeah. Right. Questions? So good. Still try to memorize our pattern. Our pattern, as we said, we have that pretty much the name will be the name for the cation plus the name for the anion. Okay? And then we have 3 possibilities for the name for the cation. Only the metal name with Roman numeral or some of those polyatomic anions, and then the anion's name have 2 patterns, IDE, or those polyatomic anions. Alright, try to name this. Okay? So you will name the cation, and then space, and the pattern you will be the cation name, and then anion name. Okay? Then we have 3 patterns for the cation name, 2 patterns for the anion name. Just figure out what the pattern. And then just the kind of you find those buckets, just put in the bucket and then you solve the problem. Okay? You said what we call the silver and nitrite. Okay? What about you see that there will be silver, silver 1, nitrite. A nitrate, a nitrite. So what is the final answer? That's the first one. Silver nitride, IDE, trite. Okay, not nitrate, not nitrite. Right. So those are not right. So that's the answer with this. Okay. Again, why we just simply name that silver, not silver 1? That's 14. Okay. Why we don't name that N like a nitrate? Very good. So those polyatomic ion nitrate you memorize. So even though sometimes the polyatomic ion probably also ending with IDE, as I said, hydroxide and cyanide. Okay? They can also end with IDE, but you memorize if I call that nitrate, which means NO3. Okay? So what I said is like this: Cn negative. Okay? Obviously, this is also a polyatomic anion. What do you call this? It's also cyanide. It's also IDE. But no matter the IDE or ATE, so all those anions in the possible anion is just IDE, ATE, or ITE. The kind of that's just like from what I you see like this is just mechanical memory. You can do the reverse. If I give you a name, just what we did before, you write out the formula, right? So this is you want to write a formula for rubidium sulfide. You just predict what will be the cation, what will be the anion, what will be our cation for this example. Rubidium, what is the symbol for rubidium? Rb. And Rb. So this will produce the cation with our positive ion, right? And and sulfide is sulfur, so that will produce our negative ion. You want to get the formula, you have to know what are the charges. Are they plus 1, are they plus 2, are they negative 1, negative 2? Alright? Okay, so RB should be plus what? Plus 1? And why is plus 1? 1, so that's plus 1. Now sulfur what?
Minus 2.
Minus 2. Okay? Yeah, very good. So now then you will get the switch. So just switch the 2 from sulfur onto RB, and switch the 1 onto from RB onto sulfur. You get sulfur 1. Sulfur 1, you don't have to write sulfur 1. Right? Very good. So it seems you're doing okay. Just be careful sometimes. So I emphasize these 2 groups of metals. So these are the 14 commonly we use. Even though we have this notation here, don't bother by this double star, which means most of the time sulfur is 1 plus, and occasionally you will see sulfur might be some other plus 2 or plus 3, but that's not that common. Okay? So these are the 14 you see here. You just use silver, not like silver 1, silver 3, silver something. And similar here, calcium, there's calcium, even though calcium 2 plus. Okay? Otherwise, for those guys, they are not here. Even though here only these few, there are many more than these few. So what do you do? Just if they are not here, just identify the metal name. For example, let's see here you have this. My very tedious example, you have this Hg2 and 2 plus, right? Hg2 and 2 plus. So what do you name this? And you see this will be our metal mercury. Okay? And then because it's like not in this group, so therefore you cannot simply call that mercury, and you have to use parentheses Roman numeral. Tell me what is the charge for each one mercury in this ion. Okay? For each one mercury in this ion. For each one mercury atom, is it 1? You think 1? And why is 1? Yeah, you have 2 plus, you get 2, so therefore each mercury is 1, so therefore this is kind of like a tricky problem. Mercury 1. Alright, so now what do you call this? If I simply call this Hg2 plus, what do we call this? Yeah. So those charts tell us, those Roman numerals tell you the charge for each one metal atom. Right. So I think this is an example that has those metals that can produce possibly more than 1 charge. Let's compare with what our naming looks like. If your metal comes from this 14, what your name looks like this, right? So your name, just simply the name for the cation without, which means metal name, without parentheses Roman numeral. If your metal not in this 14, so your name becomes a little lengthy because you have to see the parentheses Roman numeral. Right? So let's get rid of this because we are going to name this. Okay? So what pattern shall we use? Shall we use the pattern on the top or shall we use the pattern at the bottom? And shall we use the pattern on the top or shall we use the pattern on the bottom? That's bottom, right? So why use that? Why use that? Why use that? Not this. This pattern for which elements? For the 14. Okay? For the 14, let's say the 14 is similar. Okay? We memorize something similar first. Okay? If we know that similar, then we become tedious. Right? So obviously this is a PB. Is the PB on this 14 piece? No, so therefore we cannot use this. Okay? So therefore we use that. Okay? And So therefore, you know you have a PV, so this is PV, which means LED LED, right? So you use LED or LED something Roman numeral. So it should be Roman numeral, right? Now, as I said, as I tell you, we should study how to figure out what is the chart for the PV. We use the principle we studied. We said for the compound is neutral, but it means neutral positive number, positive charge equals negative charge. Right? So use this principle to calculate how much positive charge we have and how much negative charge we have. Well, how much negative charge altogether for this compound? The negative charge will come from what? Total negative charge equals how much? And that equals your total positive charge. The number, this number, right? So how many total negative charge we have in this compound? 4 negative. Very good. So how did you figure out 4 negative?
There's 4 CL.
We have 4 Cl. So therefore, I just simply start with 4 Cl, and then multiply by what? 91. Where does 91 come from? From each 1 Cl, right? Right. So when you see this Cl in it, okay, that means it's Cl1 negative. For this compound, because this compound is ionic. How do you know it's ionic? Because you have a metal. Okay? So when you see those compound like this, and you know they are totally neutral. So we go all together -4, right? And so thus we must have +4 in this PbCl4. That makes sense? Right? Because compounds should be neutral. Right? So you PbCl4, you figure out you have -4, right? And you should be neutral. So therefore your positive charge must be +4 to make it cancel out. Now, how we have +4. Okay? What ion or what element give us a plus in this compound? What give plus? I mean the lead, right? The lead Pb. How many lead we have? 1. Right? So you don't know the charge for 1 lead. You know you have 1 lead. Right? So 1 times x equals what? +4. Right? Therefore x equals +4. Right? So therefore you have to tell me this +4 use Roman numeral. Roman numeral 4 is IV. Right? Yeah.
Can you repeat that, please? I'm lost.
So let's do it again, and then you erase all those. Okay, so we want to name this, right? And as I said, we have to name this with this pattern, which means you can use lead, Roman numeral, right? And then the second part will be the chloride, right? Chloride for the Cl, right? So I think what you don't understand is how can we figure out that is 4, right? How we figure out the 4? Because we know the compound is electrical neutral. Okay? So electrical neutral. So thus total plus charge equals total negative charge. We want to figure out how much plus for Pb, right? So we have to use how much negative from other ion. So now let's question how much total negative we have. So now we know which element element give us negative? Which element give us negative?
The C.
Okay. Total negative we have from CL. So let's say each CL gives what? Give us negative what? You CL say you predict CL is -1, -2, -3. What you do, you take the group number, group 7 minus 8, give you -1, right? Okay, so each gives us -1. That means each one CL gives -1. Now then you examine this formula. In this formula there are how many CL? Yeah. Therefore you want to find out the total. So you see each CL gives -1, and we have 4 CL. We have 4 CL, right? So therefore we have 4 times -1 equals -4. And -4 is our total negative charge. Right? So once you figure out the total negative charge, then you should be able to know what is your total positive charge. So now what is our total positive charge? Well, our total positive charge should equal to total negative charge. Right? So our total positive should be positive 4. Right? So you can write, so your total positive is positive 4. You can write like total plus equals plus 4. And then we know PB gives us a plus charge. Right? That's the only one gives us a plus. How many PB do we have? So let's see, 1 PB gives us X plus. So we have 1 PB. And if 1 PB gives us +2, then just 1 times +2. If 1 PB gives you +3, just 1 times 3. Now you don't know like how much it gives you. So what do you call it? You call it 1X.
But don't you know that we have 1 PV?
You have 1 PB, because you can see from the formula, there's only 1 PB. So if just like this, how we figure out the pattern. If the PB is +2, you take 1 times +2. If the PB is +3, you take 1 times +3. But you don't know what it costs, you call that X. So then you still do the same, you have 1 times X. Right? So 1 times X should be our total plus. And you already figured out that it is +4. Right? So 1 times X is equals to +4. Then what is our X? 4. Yeah. That means the charge of 1 PV is +4. And then the Roman numeral is equals the charge on 1 plus ion.
So without doing this, can we just say that because total positive charge equals total negative charge, we have 4 negative charges, so we have 4 positive charges?
Yeah. Now this, okay. So this is relatively easy. Right? If I give you something like have more than each ion has more than 1. Let's say if I have that Fe3 and then PO4 2, and you want to name this, and you have to figure out what is the charge for Fe. So let's see, when you name this compound, and clearly you cannot name as, you cannot simply call that iron. Not iron. Not iron phosphate. Phosphate is right. Okay? So this is not right. Okay? Why not right? Why you cannot simply call that iron phosphate? few positive charge, not on these 14 bits. You only name this matter simply the metal name if your matter is in this 14. Lithium, sodium, potassium, calcium, magnesium, and aluminum, and scandium, zinc, and silver. Other than that, you have to use the metal name with a Roman numeral. Right? So this iron not here. So therefore, you have to find out what will be the charge for the Fe. The same principle. Right? So I will write something like that. Total plus equals total negative. Then make an equation. On the left side, we'll have the total plus. On the right side, we'll have the total negative. Okay? Now, who gives us the negative? The PO4. Okay? So when you call this phosphate, which means PO4 3 negative. PO4 3 negative. Right? What that tells you is, whenever you see a PO4, for each and every one PO4 together is 3 negative. Now in this formula, how many PO4 we have? Very good. So therefore, how many total negative we have? We have 2 times negative 3, so therefore we have negative 6. So we keep just see equal, right? Understand? If any question, just stop me right away, okay? Because otherwise you will accumulate, you get more and more confused. Right? That's what I like. You don't understand, just ask the question, okay? So where the 2 come from? South river here, 2 here. Where does negative 3 come from?
Negative charge.
From your memory, negative charge. Okay? So you memorize, so when you see this PO4 in your formula, you know the name, we call that PO4 together is our phosphate. Now you know the charge is 3 negative. Right? So then you can see this formula has 2 PO4. Then you know each one PO4 is 3 negative. So therefore you do this calculation. For each one you is 3 negative, for 2 you get 6 negative. So that's sort of the total negative. And that's what equals the average solution number, not the sign. That's what equals your total plus. Right? So therefore your total plus, your total positive shall be plus 6. Now let's see which that's very similar. You just use that one by one. Now you have these few similar here. You have Fe3. So that means you have 3 iron. So that's the ion that will give you the plus. Right? That was the ion give you plus. But you don't know how much plus each Fe give you. But you know how many Fe. How many Fe we have in that formula? So we're saying like 3 times something, right? 3 times what? If you know that the charge for the Fe, just keep that 3 times whatever you know, just check and see if you have that plus equal negative. But you don't know how much plus is Fe. You don't know, algebra you just call that x, right? So you call that 3 what? 3x, right? So 3x so equals what? 3 equals 6. So even though here we have a negative 6, but you know what we mean by equal, and that means the number equal, not the sign. Alright, so then you solve this, and x equals what? Plus 2. Right? So therefore, to finish this name, your name, there's probably a space here, right? And your name from iron what? What was that?
2.
Iron 2. Right? Roman numeral for iron 2 is 2 dash. If you can figure this out, and you will be okay. So this is probably the most tedious problem, right? But you have to memorize what is the phosphate, PO4. Is 3 negative, then you have to be able to identify how many PO4 do you have, how many Fe do you have. Alright, questions? positive charge for each one those metal cations, and that will be the Roman numeral. That will be the Roman numeral. Very good question. So these two is because we found these two. And these two is a positive charge for one metal cation. For one metal cation. Right? Any other questions? Alright, so let's see if you can solve this problem. So we have this FES. Tell me what do you know first? What do you know the name? You wrote the name of the cation and the anion. Do you know the name for the anion? Sulfide, okay? So something will be our something sulfide. Okay? The other things you also know, like probably know, like I think you know it right. What do you call Fe is what? Yeah, so you call that iron. And for use of iron, simply the iron or iron with something. Iron 2, right? Red, why is iron 2? So that will be the final name like that. Iron 2 sulfide.
Because sulfur is negative 2.
Very good. You see that sulfur by itself, okay? And then you can predict it. The sulfur by itself. Okay? Well, sometimes by itself, not literally mean by themselves. In the formula, you might see like some of those. So if I have that Fe2 and S3 like that, so then you still like sulfur still the so-called monatomic anion, still in some sense by itself. But the 3 sometimes gives you confusion. Because you can see 3, how can you call that by itself? That is just tell you when you have the 3, you have 3 S2 negative. In this example, you only see 1, that means you only have 1 S2 negative. Right. So that is right. You just call that iron 2 sulfide. And, so you have this 1 sulfur, so that gives you 2 negative. Same idea. You have 1 sulfur, and 1 sulfur is 2 negative. So altogether, how many negatives do you have? Negative 2. And you must have a positive 2 to be a neutral compound. Right? So now, which element will give us a positive? Which element will give us a positive? For this is similar. You only have 2 elements. Sulfur gives you negative. And which one will give you positive? Iron. Well, most of the elements like this, in the same compound, they will give you like 1 charge. Whereas some of the elements, we are not worried about that in this class right now. We will give you like 1 element will give you 2 different charges, but you don't worry about that now. So therefore, Fe gives you the positive, and how many Fe do we have? Only 1 Fe. And so therefore you have 1 times 2 plus, so therefore you have this 2 plus. Right. So the other way is simple. So if I give you this, you want to write the formula, right? Just review what we did for the first few seconds. Okay? If I write ruthenium 4, which means you have that positive ion Ru. Ru, what is the charge for each one Ru? You just use the Roman numeral to the reverse. So therefore it's 4 plus. Oxide, which means O, and O will be 2 negative. Right? So probably not that simple, but after you get this, you switch, and you will get that Ru2 and O4. Right? And then what do you do? If you get RU204, what do? You simplify, okay? So therefore you change that RU204 into RU02. Right, so then the next is about the naming pattern for those polyatomic ions. So when we see the polyatomic ions, you treating them as single ion, even though like they have more than one atom in it. Often you can identify them by the parentheses around them in the formula. And the name and the charge of those polyatomic ions do not change in most of the chemical reactions. If they change, they change. I mean, in some of those redox reactions, for example, oxidative reduction reactions, they will change. But in most of the chemical reactions, they will not change. Then you follow the similar pattern. If you know you have those ion in it, no matter they are monatomic or polyatomic, you just name the cation first and the anion second. Okay. So those polyatomic ions, sometimes I cross them, so therefore you put that in the quotation mark. Not always true. Polytype. Why I cross that? Because I will use that. If you think about that, so sometimes you will get less confusion. Okay? For example, the last problem I did not finish is that Fe2S3. So even though you see here you have a 3 sulfur, and you don't call that a polyatomic ion because, as I said, most of the polyatomic ion is actually polytype. But a few is not a polytype. Okay? Peroxide, so you accept that O2 2 negative, and then that Hg2 2 plus. Okay? So those are also polyatomic ion, and obviously they have the same atom. They have more than one atom in it. Okay? So other than these few, most of the polyatomic ion actually polytype. Hydroxides, sulfates, nitrates, carbonates, acetates, they all have more than one type of atom in it. Usually you get confused by those kind of patterns. So you write that, you see clearly you have a 3 sulfur. What do you call that? You call that 3 sulfur is a monatomic anion or polyatomic anion. If you memorize those polyatomic anions, most of them in polytype, you can separate that few, then you know this sulfur here, even though you have a 3 sulfur in it, then you know each sulfur is monatomic. Right? So it's not precise, but just in your mind, when you see polyatomic, try to check in the polytype. And then you memorize that few that even though they are the same type, you still call them polyatomic ion. Right. So then the other one will be the memories. So this table is the most common polyatomic ion, so I want you to memorize them. Okay? So the first one will be C2H3O2 negative, and you call that acetate. And then you have the CO3 2 negative, and you call this carbonate. And you have HCO3 1 negative, and you call this bicarbonate, aka hydrogen carbonate. Alright, so now you have OH 1 negative. Memorize those formula, memorize those names, and memorize their charge. CrO4 2 negative, chromate, Cr2O7 2 negative, dichromate, and negative, nitrate, NO3 into NO2. And then you use that. NO2 and negative, but then what? Nitrite. And then last one is NO4 1 plus. I think most of you already know that. Ammonia. Right, so the other side, you see that table on later notes. What are those chlorines? Chlorine, bromine, iodine is a very interesting element. They can possibly produce like 5 of those different anions. Okay? So let's start with Cl1 negative, even though this not belong to here, but I'll put right here, Cl1 negative, because that not belong to this polyatomic ions. So just as give you a complete picture, when you have a Cl1 negative, you call that what? Chloride. Okay, Cl1 negative, we call that hypochlorite. Cl2 negative, chloride. Cl3 negative, chlorate, and Cl4 negative, chlorate. SO4 2 negative, you already know that, right? Sulfate. SO3 2 negative, sulfide. That gives you a pattern. So if you have, you know something, ATE, one less oxygen atom with ITE. Right? Then you have this HSO4 1 negative, bi sulfate, HSO3 1 negative, bisulfite. The last two they also have some other name. You can call that hydrogen sulfate, hydrogen sulfide. So try to memorize. Those are very, very common. Very, very common. You will see in a lot of programs. So that's this table. And this guy, right? Probably the same. Let's do some practice. Some of those compound contain ions, polyatomic ions. How do we name this? Li2Cr2O7. If you don't memorize those polyatomic ions, you will be in trouble. You will try to name every element here. You have lithium, you want to name lithium. You have chromium, you want to name chromium. You want to have oxygen, you want to name oxide. But if you know there are polyatomic ions, so these together you call what? Dichromate, which is standing for Cr2O7 2 negative. So once you know that, then you just name that. You know this compound is ionic because you have metal in it, right? So just use our naming pattern for naming the ionic compound. You want to get the cation's name followed by the anion name. So I already give you the anion name. Anion usually you sort of memorize, and then the cation you just get information from reasoning. Right. So our metal is Li, right? Then you have two possibilities. You can either name that lithium or lithium something. Which way shall we use? The first one. Very good. You still remember the 14. Lithium is 1 with 14, right? So therefore, you don't have to worry about this 2 subscript 2 on lithium. And these 7, those information get lost because those store in your memory. Right? So altogether, the lithium dichromates. Right? Okay, so what should you name? Let me this is what I write. What do you name this guy? SnClO3 2 negative. If I right now we know we are naming those ionic compounds. Okay, so on the test on the exam, if I don't give you those information, you see like naming ionic compound, you have to go like a little like one few steps backward. You first identify what you have. Remember today we said we're learning like naming 3 compounds. Ionic compound is one type. Right? Yeah, so that's the first type. Later on, pretty soon you will learn to naming the other 2 types. The binary molecular, the acid. So if I don't tell you, you review one step. You first identify what you have. So each like a category. Each type of compound have a pattern. If you know your compound is ionic, you know you should name the cation first, then anion. And your cation has that 3 pattern. And your anion has that 2 pattern. Alright. So what kind of compound we have? Ionic, because we have metal in it. Even though you don't have metal in it, don't stop. You're checking if you have ammonium. So this ionic compound, right? Therefore, you name the cation and anion. Usually the anion will come our memory letter first, even though we are going to name the second, because that's most of the anion you just polyatomic anions you can memorize that, right? Okay, so we are going to name our cation, then we are going to name our anion. Our anion in this example, I will give us, we'll start with chlorate. Okay? Chlorate, which means we have a ClO3 1 negative. Even though in the formula you don't see all the information, you don't see the negative here. But at least you see ClO3. ClO3. But you see more, you see you have the parentheses and 2, which means we have a 2 chlorate. Each 1 chlorate again is how much negative? 1 negative. Now again, how much chlorate we have? 2 chlorate. Therefore, what is our total negative charge? How much negative we have altogether? Negative 2, right? So according to our second principle, negative 2 should be balanced by how much plus? Plus 2, right? Okay, now, who gives us plus? The metal, the only 1 metal here, Sn. Okay? Only 1 metal, Sn. So therefore, the positive charge on 1 Sn is plus what? Plus 2. So therefore, you know your Sn is plus 2. So Sn is Ti, tin, right? So should you use tin and 2 to indicate that 2 plus, or should you use simply tin and so tin 2 chlorate or tin chlorate? So which of these 2 is right? Our first one is right, or our second one is right? The first one is right. Again, you just use elimination. You know that Sn or tin is not on that 14 list. You're not on that 14 list, and you have to. Okay? You have to use the Roman numeral and parentheses, because otherwise, if you simply tell me it's tin chlorate, then when I try to communicating back to you, and I will not be able to tell you whether we mean the same thing, because tin sometimes is 4 plus, and sometimes 2 plus. In this example, it's 2 plus, right? It's all about the clarity. You want naming the formula is very, very clear. Right, so let's do the reverse. If I have a name called the cobalt 2 phosphate, so how can we get a formula? That we learned in the first few sections of Chapter 3, right? You want to get the formula, you have to get the same power, right? So you want to get the same power of cation and also the anion, right? So let's first get the same power for the cation. What is the same for the cation? We said what is our cation in this example? Cobalt is our cation. Very good. So cobalt is metal, so therefore we have CO. And cation, bringing plus charge, plus what? Plus 1, plus 2. How do you use plus 2? Very good. So this Roman numeral is 1 to 1 is equivalent. So that means how much positive charge on one ion. So therefore we have CO 2 plus. So this will be our symbol for the cation. What should be our symbol for the anion? Phosphate. Phosphate is very typical, very typical like the anion. Again, a lot of those fertilizer has phosphate, and also commercially is very important. Phosphate. Anyone remember the formula for the phosphate? So because you have phosphate, that name that means it's phosphorus PO4. The charge. And what everyone knows? 3. Very good. 3 negative. Alright, so once you get these two up, you just review what you did in the first few seconds. What we did is doing what? Switching, right? Right. So we'll take these two and onto this PO4. Then in the formula you don't have to show those charge anymore. Right? So right now I have this formula. Shall we simplify this guy? Shall we simplify this formula? No, which number comes from a switch? These 3 come from a switch, these 2 come from a switch. And that means the ratio between 3 and 2 is already symbols. Right? So I think that's about it. So I think what we want to emphasize is this Roman numeral is the charge for one ion. Okay? So sometimes you probably confused because you think about it for like a few more ions. But that's just for one ion. Right, so now you do the practice. B. Okay, why B? Why not C?
In the list.
Very good. So if beyond that 14 B's, you don't use Roman numeral and parentheses. Very good. Try to practice this. What's the name of the FE203? C? C or B?
C.
Why is it C? You find out that that FE is 3 plus, right? Everyone agree? Right? So you pretty much have this give you a total negative. You can calculate it very quick because you say that 3 O's, so therefore you have 3 times each O give you how much negative? Negative 2, so therefore you have negative 6. So therefore you're going to use this 6 to figure out the total plus. Right? Right? So we will have 2 times x equals positive 6. What do we mean by the x? The plus charge on what? On how many ions? You have altogether it will be 2 times, right? So this 1x is plus on 1 Fe, right? Very good. So you solve that, you get x is plus 3. Right? If you find out x is plus 3, okay? X is the charge on 1 Fe. And this is 2 Fe here. Right? Very good. So that's a C. Try to name this. A. You get kind of get the idea right. You identify this is ammonia. I think E is the final answer because once you identify this, so this is our cation, right? And you call this is our ammonia. Then you just be careful, these guys together, so you have a ClO4. And you can see here, these are the few ions that all have Cl in it. In addition to this four here, you have another one that don't have oxygen in it. You have that. You know the name for this. This is called what? Chloride, right? Chloride. Right. So altogether, those are the few common ions that have Cl in it. And just memorize, just be careful. Okay? So therefore, the answer is E. Ammonium perchlorate. Right. This will be our second type of compound. We call that binary molecular compound. This is very straightforward. It means your name, your compound has two different type of element in it, and each pattern is two different type of non-matter in it. So usually you will write them like in this way. So you will write one element first, then write another element. And how much atom for each element, you use the subscript. So then which element you're going to write first, just in case you're wondering. You don't have to worry about that too much. So I'll give you this sequence. And this sequence, this table, you can use this table as what I give to you. But you can use this pattern. So which one you write first, you just pretty much use those elements that is far to the left or far down the same groupers. That means those left and lower corner, those elements in those locations, so those I'm going to write them first. You can save these two are even size in red, so these two are equal sections. So that's probably not that important. What is important in this setting is how to name them. So you have a binary molecular element, a binary non-matter molecular compound in a molecular compound. You have one non-matter, another non-matter. So therefore, the basic name pattern is to name the first element as just element. Name the first type of element that you write first as use like the complete name, use the full name. The second type of element, you don't use the full name. Use the stem and then just use IDE. But that's not all. You can see I have some of those. You have to use a prefix to indicating how much atom you need for each type. But that's not all. That means a prefix there's one interception. And if for the first type of elements there's only one atom in it, according to our pattern for the prefix for the mono, but you never use mono as a word on the first element. Right? So then summarize our pattern for this type of naming, except those common name, is here. Prefix with like the first name for the first element, then prefix with the stem of the second element with IDE, and obviously here will be a space between these two parts. Alright, so that's our second naming pattern. So again, I will see, we are going to put these two elements side by side. Our first element, second element, and which element you write at first, which element you write second. Basically, the more metallic element write first. Now, which element is metallic? Left lower corner. Okay? With the exception that H will be written behind nitrogen, that O will be written before the fluorine. So that's the two intersections. Other than that, you pretty much use the left lower corner of those elements written first. Once you have those written up, so that's where our usual problem. I will give you those formula, you name that, or I will give you the name, you try to get the formula, but anyhow, I will give you the right sequence. Write a letter first, name letter first. And then the name pretty much just first element name with prefix, no, and then the second element name with prefix, not the full name, but IDE. So that's what I try to see here. So the first one will be the prefix with a full element name for the first type of element. The second one with the prefix plus the stem plus IDE. Let's see my number. If I have my number, let's see N2004. Right? You want to name this compound. Again, if I don't tell you this is binary molecular, you have to tell yourself it's binary molecular. You just do one by one. Is this compound ionic? Is this compound ionic? We have metal in it. Okay, then we don't stop. We have ammonium in it. You know what is ammonia? H4. So we don't have metal, we don't have ammonia, so therefore it's not ionic. And then we also have acid. We're not studying acid yet, but I tell you this is not acid. Acid usually is written, have an H written first and have that A for acid, and you have an H written first, like HCl, and also followed by the state EQ. So maybe just first identify what you have. So I'll tell you right now we have binary molecular, so therefore you don't worry about that. When you name the binary molecular, you will name this pattern here. So prefix with element name, then space, and prefix with stem plus ID. Even though the prefix for the first element is not always there, but most of the time they're there. Right? So what is our, let's see, identify the two elements first. What is our first element? Nitrogen is the first element, so therefore you're going to use the full name. You don't use like nitrites, just use nitrogen. Right? So what is our second element? No, that's opposite. Oxygen, you don't use oxygen the full name, you call that oxide. You just take the stem for oxygen is OX. Alright, so these two parts, well, I didn't do enough space. Then you have to use it, for each of them, you have to use the prefix. The prefix you must use for those binary molecular compounds, because that will tell you how many atoms are in there. So how many N we have? 2, so therefore we have to use the prefix di. And how many O we have? 4. Tetra is our prefix for 4, but if you have that oxygen inside with O is wow, so therefore you draw this A. Okay, so the second part will be our tetroxide. So this will be our name, and this will be our name. And you just leave a space between them, and that will be the full name. Right. I think those prefix for those subscripts, what we see here is the one-to-one connection. Okay? If you see that one is a mono, but you don't use that mono for the first element. Okay? Remember that, you usually gotta forget. Okay? So 2 is di, 3 is tri, 4 is tetra, penta, hexa, hepta, octa, nona, and deca. So those are the common prefix, 10 of those. If you have more than 10, you will use udeca, dudeca, or something like trideca. I think you should know those prefix too. Alright, so let's name like this a few. Right? What do we name this first one? Ni3. Let me enlarge them. Ni3. What is our first element again? Therefore, just need to call them nitrogen. How many nitrogen we have?
1.
Do we use mono?
No.
Very good. So don't use mono for the one, for the first element. What is our second element? Iodine. And then you just don't call it iodine, call it what? Iodine. So then, again, I don't give enough space. So that's it, right? Then inside the space. Nitrogen, triiodide. Right, so let's see, we have the element PCl5. Very similar pattern, right? Those are all molecular compounds, all binary, so therefore I skip some of those analyze. They are not ionic. So we name the first element is what? Phosphorus. And then this time you have space. And then the second one will be our chlorine. Very good, very good. So you don't call that chlorine, right? Don't call that chlorine. The second element in your molecular compound, okay, just drop the anion and add ID. Right? So now we have to use prefix for them if we need to. The first one, how many phosphorus we have? Do we use mono?
No.
Okay, don't use mono. And then this one is what? Yeah, pentan, 5 pentan. Alright, now we name the other one P4S10. Okay, so again, this is phosphorus, right? So this, you have to do prefix now, right? 4 will be what? Tetraphosphorus, you already have to capitalize the letter. And then space, continue with that. That one will have to come from sulfur, then called what? Sulfide. And then this will be what? Deca. Alright, so that's relatively easy. Now you do a practice. PI3. Charlie C. Charlie C. That's familiar. Yeah, that, okay, that's yeah. Everybody agree? So then determine the formula pair, which one is right? Okay, so I adding these two emphasize and never use a prefix for the ionic compound, and vice versa. You never use Roman numeral for the molecular compound. Even though in this example I don't have those mistakes. Alright, well, which one is the right answer? Right pair? B. Everybody agree? B. Yeah, even though it's yeah, that's the answer. So let's try to keep all the formula and then get the right name. Okay? Or you can, I will get this part. I will keep do the formula, then get the right name, and you do the reverse. When you have time, you will keep all those names, and some of those names are not right. If the name is right, and try to get the formula. Right? So those formula is right. So therefore let's get the right name. What was the right name for the first one? Very good. So the only mistake here is we miss what? Miss prefix. Agree? Okay, excellent. So then the P obviously is right. So what should we change for that angle 3 to get the right name?
Get rid of the mono.
Very good, very good. So now we use a prefix for the ionic compound. This compound is ionic, right? Mono is a prefix. Okay? So if your compound is ionic, don't use a prefix. Because prefix, the purpose of prefix is tell you how many of those ion you need. Okay? And you can find that out from the chart of the ion. Right. So what is the right name for the K2O? You will drop both of the prefix, right? Let's drop this one and drop this one. What should be the right name for this one, for E? Very good. So this will be the RN3 oxide. If I tell you to do the reverse, if those names are right, I think you accept that C and D those names are not right. But you can change the A and E. So if you do that, okay, you write the formula from the name of A and E. Okay, so that's the two tedious of naming, so not spend that long. So then the last group of compound is acid. So acids usually when we have the H written first, and then followed by the AQ. So that's how you identify usually in this class what is acid. And as you learn more and more, you will see that more different ways to write acid. You don't have to write in a specific pattern, but let's begin with those. Okay? And then I think the book calls those acids a little different. So, but I think it's a little straightforward. I just call them like in this way. You call them like some of the acids don't have oxygen in it. You call them non-oxy acids. So very straightforward, right? Non-oxy acid, which means those acids do not have oxygen atom in it. And so then the other one, what with the other possibilities, is the oxy acids. And very straightforward. Oxy acid, which means the acid has oxygen element in it. Why we emphasize that? Because you will have a totally different pattern for naming these two different types of acid. Right. For the non-oxy acid, and you will see in the formula there is an H, and there will be some those like one of those non-metal anions. And then most of those non-metal anions will be those IDs. Then those oxy acids, as we said here in this class, even though in some other class you don't have to follow this pattern, you will have the H written first, and H will be our kind of our cation, because when those acids in this state, which is called the aqueous solution, which means dissolving water, so that the molecular formula separate into H plus, and then those leftover anions. You might take 2 steps to do the separation, you might take 3 steps, but at least for each step, you will take one H plus away and produce a new anion for each step. Right? So then for the non-oxy acid again, you will have that H plus come off, and then you will have those leftover remaining. You might have some of those just simply leftover become like one of those non-metal atoms. You might have still have H in it, but just take the H off like one by one. Okay? So once you take those H off, you will have those leftover become anion. So then the naming for those acids strongly depend on what you have left over after you take off those H plus, the so-called anions. So first of all, the two large patterns, one big difference is the use hydro. This is called the prefix for this non-oxy acid. And then you identify what is the ending for those anions that are left over after you take the H away. And then you just do the kind of a translation. If you have the left over anion ending with IDE, you just call that something IC acid. Right? So we'll do those translations in more details. But now let's see. We have these two types of acid. Non-oxy acid, very straightforward, that means they don't have oxygen atom in it. So your name pattern with the hydro, okay, plus the base name of those non-metal, and plus IC acid. Let's see a few examples of those. So let's see, we have this HCnAQ. Okay. So if I take H plus away, so So therefore, I will have H plus become equals solution. So this comes from the HCN EQ. Right? Then other part of the CN EQ. Now what will be the charge on this CN? If I take the H plus away, what will be the charge on this CN? Huh? -1. Yeah. So then this guy called the cyanide. Right. So then this assays we write here. We have H first, and we have aqueous solution. Right. So how we name this? Well, you see this is a non-acid assay, so I will follow this pattern. So you first use one prefix called the hydro. And then when you name, you will just drop that IDE, okay, and change that into IC. Cyanic acid. So as a compare, okay. So if I have an acid that has oxygen in it, so HOCN, and followed by the stated aqueous. So this also acid. If I take the H plus away from this guy, once you take the H plus away, that will become H plus aqueous. What left over is OCN aqueous, and how many negative on this guy? Then -1. -1 in this case is like most of the negative is on the oxygen atom. Okay. So this anion has a name cyanate. Right? And so therefore the name for this acid will be a different pattern. You have that oxygenate. If you have oxygenate, you cannot use hydro. So what do you call this acid will be our cyanate acid. Right. One more example. HF equals, what should we call that HF equals? Yep, so the hydro fluoric acid. Right. So that's about two examples for this first type, non-acid acids. You can see both of them have the hydro. Right. So then I have one example for the acid acid, and in this example I don't have a hydro. And my anion ending with ATE, and I change that into IC. Right. So let's try to name that. H2SO3 equals. Do we start with hydro? No, because this has oxygen in it. Okay? And so then what you do is identify the anion that's left over if you take all those H away. SO3, 2 negative with the anion, you take all those H away. Right? So then what do you call this? Because then this ion is called sulfide, right? So because this ion is sulfide, so therefore the name for this acid will be the sulfurous acid. So you can see in this translation we change the ITE into OS. And in this translation we change the ATE into IC. So this is the pattern we see for the acid acid. So if the name of the oxygen anion ending with ATE, and you will change that into IC. So even though sometimes IC is not that straightforward, because you have adding like a few of those letters, make the pronunciation look like easier. So if the anion ending in ITE, you change that into OS. So See the 3 pattern for the acid? Any questions? Seems need some more practice, right? So make sure you remember to use hydro for those non-acid acids that are emphasized here, and vice versa. Don't use hydro for the non-acid acids. So let's first practice as non-acid acid. So we have this HIAQ. What should we call this? Is this acid? Is this acid? This is acid. H is written first. So 2 things tell you this acid. Okay? So do you have an acid H written first? Then you have that state aqueous. So this acid, what kind of acid is this? Is this acid acid or non-acid acid? Non-acid acid. If it's non-acid acid, what's you starting with? What's your name starting with? The hydro. Okay? Hydro. Hydro what depend on the anion that left over. Okay? Hydro. Let's see, the left over ion is this ion. Anybody know this ion's name? Iodide. Iodide. Then you just change this IDE into what? IC. For most of the time you can do that. Change the IDE or the ATE into like those IC. For a few of those, you probably have like a sulfate. You just sulfuric, right? All right. So what do we call this? What do we call the second one? HFAQ. Is this acid or binary molecular compound? It's a binary molecular compound, but might not become acid because that's dissolved in water, right? So therefore, you're going to use those acid name patterns. Do we first of all decide do you use hydro or not?
Yes.
Okay. So that's because there's no oxygen in it. Hydro needs to become what? Yeah. So that will become depend on the ion. Hydrofluoric acid. Very good. Very good. Okay. Now you already saw this for the oxy acids. You have like 2 more patterns. So the oxy acids, after you take those H away, you will have those ions possibly ending with ATE and possibly ending with ITE. Right, so my example is this. So what do we name this HNO3 aqueous? How do we name this acid? First identify is this oxy acid or non-oxy acid? This is oxy acid, right? This one. So this is oxy acid, right? So when you name oxy acid, do you use hydro? No, so don't use hydro for the oxy acid. And so then, according to what we said here, you just identify those polyatomic ions left over, polyatomic anions left over after you take those H away. There's only one H you can take away. You take this H away. You take this H away from this formula. What you get is NO3 by negative. Anybody know the name of this? Nitrate. Nitrate, right? Nitrate, ATE, right? Right. So then, according to this, what we said here, if your name ending with ATE, and then you know your name, your ending for the acid or IC, you might, before the IC, you might add in some letters. So for this example, we can simply draw this ATE and become IC, right? So therefore, the name become nitric acid, right? Not that like that, but just just identify like what is the name for the anion, right? If the anion's name is ATE, then you know your name will be IC. Okay, so that's the other pattern, right? So the other pattern is, after you take those H away from your formula for the assay, you get the anion, and then your anion's name will ending with ITE. I think here is my example. So here we have this acid. Is this acid acid or non-acid acid? Acid acid, so don't use hydro. Right? Now let's take the H away and see what we have left over. Everybody see this? If I take H away, what do you have left over? Yeah, so you call that this equals, I just tell you the state, but you still call this is our what we call this iron nitrite. Nitrite. I mean, you don't get confused. You are jumping one step. You call this acid nitrous acid, but you get nitrous because you get this nitrite, right? So you're okay. You jumping one step. So you first identify. If you know that, you don't have to identify. Just you identify the ITE, and then the ITE in the translation become OUS. All right. So that's about those assays. So let's see this practice. How do we name this? This again is acid, right? Because acid, we say we have two ways to examine the acid. One we say this acid have H written first, even though this is organic acid, in organic chemistry you will know by something like that, right? So this acid, and we have the H written first, we have the AQ, which means aqueous solution. So you first identify, if you take the H away, what do you get? If you take the H away, you get that H become plus, and that means it dissolves in solution and separate from the rest atom. Right? So what left over is a C2. You still have this all together, C2H3 and O2, and still that's also same state because that also dissolved. Right? What is the charge for this ion? -1. Right? So then anybody know the name for this ion? Acetate. So we have acetate, which means you ending with ATE. Okay? And then you see what's your naming starting from? Do we have oxy acid or non-oxy acid? Oxy acid, don't use hydro, right? So therefore, we just simply change this guy into what? Very good. So this will change into IC. If you have ITE ending, then ITE you will change into what? Very good. So what is OUS? So then the name for this will be our acetic acid, and you hear that a lot. Right, try to name this. You already know the name of this, right? This is what? Nitrous acid. I think I'll do a reverse now. If I give this perchloric acid, so what's the formula? You first identify, if I give this name, do we have a hydro in it or not? No hydro, that means our acid is an oxy acid. That means our acid has oxygen in it, right? Yeah, our acid have oxygen in it because the name don't have hydro in it, right? So then those chlor, which means you have chlorine in it, right? Now chlor what? You can have chloric, chlorous, hypochlorous, and this is the perchloric. Perchloric, this A that means come from what?
ATE.
Very good, so that becomes ATE. So therefore you have this perchlorate. So then let's translate perchlorate into the formula will be our ClO something, right? O4, 1 negative, right? This is kind of like hard memory, you just perchlorate, so ClO4, 1 negative. So you get this anion, right? And then what is our cation in acid? H plus. So H plus will be our cation. Then once you get the cation, you get the anion, you just, like what we did for the first few sections of Chapter-3, you just switch. So then you switch it just O1 1, so just HClO4. Then one thing you don't forget is what? Aqueous. Right, so then let's do some little practice. Now we already learned all those three compounds we learned in this chapter. Right? What are three compounds we try to name? One compound is what? Ionic. The second one is what? You can see binary molecule. The other one is what? Acid. So each of them have more details. Okay? So I have these few examples. You want to name them? No, you have to put everything together. Okay? You first identify what you have. Then you go by those patterns. Let's see the first one. The first one is the CO. What is the CO? Is CO acid, ion compound? What is CO? Very good. So belong to this type. Right? So in this type, make sure you don't use parentheses Roman numeral, but you probably have to use prefix. Right? So the pattern is like this. So the pattern for those molecular compound, you will see the name for the first element, which means the full name for the first element. You have nitrogen, you have N nitrogen, you have like carbon will be C will be carbon, and P will be phosphorus. The second element, you don't use the full name for the second element, right? Only the stem for the second element with ID, then both of these two elements possibly can have a prefix. With the prefix, you have to be very careful. The prefix you have to be careful with what? The mono on the first one. Okay? Right, now let's try to name this. So who is the first element? Who is the first element? Carbon. Carbon? Carbon. How many carbon do we have? Do you use a mono? No. Only mono. And so therefore that finishes the C. So that's that we just have this carbon. And then what is our second element? Oxygen should be our, you use oxygen the full name or what? Oxide. Very good. Oxide. And then, should we use the prefix or not? Even though it's only one, right? Monoxide. Right, so that's it for the first one. Right. Any questions? So just be careful. Just give something you want to name. Just first know what you name. We have an ionic compound. We have a molecular compound. We have acid. Second one, CaF2. What do we have? Be careful. Is it ionic? Oh, it's ionic. Why is it ionic? Because it's metal. But usually you don't see that's metal. If you don't have metal, you just still want to check whether you have what? Ammonia. So that's like just easy struggle. So we have ionic compound. Ionic compound, we have two naming patterns. One naming pattern is just simply naming the metal. That is simple. The other name pattern is the metal name with what? With Roman numeral. For this metal, shall we use the simple pattern or shall we use the metal with Roman numeral? Simple, because this calcium belongs to that how much there? 14. 14 or 4. So therefore you will call that what? Calcium? Not the calcium 2. Okay? Not the calcium 2. Or not the calcium 1. You see, or not the monocalcium. Okay? Just calcium. Then the second one will be our negative ion, F1 negative, right? For our fluoride. Calcium fluoride, so that's it. And then you can see it seems like you lost some information, but you are not. Right? You don't see that information 2 here. Right? You don't have to use that information. You don't have to use like dye to tell us we have 2 fluorine, because you can figure out that you have 2 fluorine by the charge on the CA. So simply you get it, right? So what do we have for this one for number 3? HF equals Is this what? Acid?
Yes.
Non-acid acid?
Yes.
So therefore, you're going to name that acid. Let's switch the side. So let me do this one. So acid we have two types, non-acid acid, which means you have to sign with hydro, right? And acid acid, don't use hydro, but you might use those IC if you have ATE or US. Alright, so our non-acid acid, we have to use hydro. Okay. So that hydro what depends on what we have for the anion. What do we have here? If I take the H class away, I have F1 negative. And the name for F1 negative, I think you know what? Chloride. So therefore the name for this guy was what? Hydrofluoric acid. Very, very important. This hydro or not hydro make a difference. Alright. So let's try to continue with the other one, with number 4, with this one. What kind of compound is this? That's ionic, right? So let's see, we want to name this compound ionic. How you name an ionic compound? You have to name the cation, name the anion. The cation, the name, maybe very similar, just a metal name. Maybe Peleus, a metal name with what? Roman numeral. So for this one, shall we just use a metal name or use Roman numeral? Very good. Now, this structure Roman numeral because this metal is what? Fe is not in the 14. Right? So we have to use RNA something. This Roman numeral tell you what? What is this Roman numeral standing for? The charge on how many atoms? On one atom, on each one cation. Right? So therefore, you have to figure out. So how many Fe we have here in this formula? One Fe. And how many other ion we have? The anion we have is how many? 3. We have 3 NO3 one negative. And so therefore, you have 3 of these, and each one of these gives you -1. So what is our total negative? We have a total -3. And then what are our total positive? -3. Okay? Now the total positive 3 will come from how many Fe? So therefore this Fe is plus what? 3. Alright, very good. So 3 plus. And the Roman numeral will be Rn3. And what do you call this guy? Nitrate. Very good. Alright, so someone knows something, but I think that's good. So you just keep studying your like memorize those patterns. I think that's the interesting part. Alright, so let's try to move on with this HCl04, right? HCl04 aqueous. What do we have for this HCl04 aqueous? Acid. What kind of acid? Acid acid. So no hydro, right? Alright, so that's a switch. And let's see the pattern for naming the acid. And how do you name the acid? How do you name this acid? HCl04 aqueous. Hydro? No. You already have that something like the oxygenase, so therefore don't use hydro. What do you name? You take this H away, see what you get. Right? So if you take the H away, what you get is Cl04. Am I right? Then you know whatever the negative, right? Negative, I think I have this. We're in the same state. Do you know the name for this? You forget about the state? Very good, very good. So here we go. Perchlorate. Just remind you, if you have Cl03 negative, this one is called what? Chlorate. That is the reason we call that CRO for per rate. So per means a little higher, right? So that's the reason we call it per rate. And then this is just core rate. This is core rate. If you have even less oxygen in it, you will have a CrO2 one negative. Then you call what? Chloride, because ITE and ATE difference is more and less oxygen. You will have this anion, so you have like a lot of more, you just use per. You have a lot of less, you just hypo, right? All right, so then we don't use hydro, we just simply, most of the time just simply do the translation, so this becomes what? IC, so therefore you have the chlorate, adding, yeah, so you adding more acid, right? Any questions? Good. So the last one, H2SO3 aqueous, so what have we named that? Ionic compound? No, we don't, yeah, acid again, right? Obviously this is oxy acid, we don't know this, right? So again, if you take the H away, we have a 2 H here you can take away. Now how many H you can take away? You take those H written first away. So in this class we will just do something like that. I mentioned about take those H away one by one because that depends on the program. For the naming, you probably don't have to worry about that. But in the later on in chapter 4, when we write those chemical equations, or like in some other chapter, in chapter 4, I remember also like in Chem 1 or 2, you take those H one by one away. So for this naming part, you take all those H away and then see what you get. So you have H2SO3 aqueous. So if I take both H away, again I will take that step by step. Okay? So in one step I will take one H away, that becomes H plus, and then that, and so then I will have the other one will be the HSO3 one negative aqueous. And this is still acid, but this can be amphoteric. It can acting as an acid, acting as a base, depending on what you react with. If you react with some of those chemicals that are more basic, and that they will be acid. So therefore, you can take another H away, and so that's produce another H plus, and then you will have this HO3 2 negative aqueous. So in this formula, this is the one you have to worry about. So see what you finally get after you remove all those H. But in details, you get some idea for now. When you have those H has more than one H, you take them away one by one. And each step, you can do a different calculation. You can also have different strengths. All right. So what do we name this SO3 2 negative aqueous? Or forget about the aqueous, just name it SO3 2 negative. Sulfide. What do you name it as S2 negative by itself? Sulfide. What do you name it SO4 2 negative? Yeah. Very good. So know some of the common name for the same element. And then you use them in some of the problems. So this is the ITE. We have the oxygen in it. What do? You know your adding will be OUS, but you might adding like a few letters to make the spelling a little bit easier. So for this guy, you know we have the OUS, and just for the English language, I think that right. So that's. So you call that sulfurous acid. Right. Any questions? Wait, now you try to. I think I already tell you the answer for that one. Name this acid. write a formula for chloric acid? Which one with the chloric acid? You think it's C? Very good. Right, now let's get out the name for all of them, right? So this is chloric acid. It means we want to get a name for each of these. So what do you call the first one? A. Hypochlorous acid. What do you call that? B. No hypo. So it is simply chlorous acid. What is D? You already saw that, right? Chloric acid. What do you call E? Very quick. So that was the hydro because you don't have an oxygen in it. Hydrochloric acid. That will make a huge difference. HCl, hydrochloric acid, a strong acid. If you simply call it chloric acid, HCl03, that it's kind of moderate acid, not that strong. It's kind of call that weak acid. And you know what. So we will do some little practice. So I have those PDF. So you get on iCameras and you first get the one don't have answer. So don't know how to have. And then you can also go to this website more practice. Okay? Let's start a few more seconds, otherwise it will be like 10 minutes. Right? So I'm late, so usually like I will not have a break. So we have we already started in Part-2 how to calculate some of those conversion from gram to mole, from mole to members. We continue some more in this chapter. Okay? So before we do the calculations, obviously you want to know how to calculate what is the mass for one molecular, or what is the mass for one formula unit, or what is the mass for one more of those molecules. Right? When we do those calculations in Chapter 2, we can find out the mass for one atom very easy to use the periodic table. But when you have some of those formula, and you have to know how to read the formula, and how to multiply, and how to add. For example, if I tell you we have water, then you know the water formula is H2O. Right? So in each one H2O molecular, you have two H atom, one oxygen atom. And you can use those information to figure out the mass of one molecular of H2O by take the mass of one H multiplied by 2 because we have 2 H. Then adding on to the mass of 1 O because we don't have 1 O. Then altogether we get 18.02 AMU. Then you know what unit we use. We use AMU because we refer to one molecule. Only one molecule. Molecule is very small. Right? It's so small it behave very strange. It behave as like sometimes behave as waves. It's oscillate. You cannot really measure that precisely where it is. So therefore, you first calculate and first learn how to calculate the formula mass. Okay? And if I have this for the glucose, this is for the other fructose sets. Those are isomers. So what you do, just take this formula, read it, see how many carbon we have. 6 carbon, so therefore we have 6 times 12.1. And this will be the AMU because we want to calculate the formula mass. And then how many H do we have? 12 times 101. Right? How many O we have? So 6 times 16.00. And that's how you, all those will be AMU. So this will be AMU. Yeah, so that's easy. Now that's what, if you know everything, you can do numerically. But if you don't know the name, then you are screwed, right? So you want to get some calcium nitrate. So what is the formula for calcium nitrate? You have to do a translation. Calcium is what? Ca how many plus, right? Nitrate is what? NO3 what? 1 negative, and the calcium is 2 plus. So you do the switching, you will get CA, and then angle 3, and angle 2, right? Angle 3, 2. So therefore, you have this formula. You want to calculate the formula mass, you just see how many each atom do we have. Now we have polyatomic ion, which means you have the parentheses with the subscript. You have to read this carefully, because you have this in the parentheses. Right? So how many CA we have? How many CA we have? 1 CA. Then you just see what is the mass for 1 CA? 40.1. 40.7 away. Right? Now the problem, how many N do we have? 2. Very good, very good. How do you know it's 2? Even though here is only 1. This is subscript referring to everything inside, which means you take this subscript multiply by whatever number they have by themselves. Right? So therefore we have 2 times N, so 2 times what? 14.1. And how many oxygen do we have? 6. Okay, good. So if we know that, so then I think the next section will become a little easier. Because you know those, in the formula you have those so-called, use the formula as converting ratios, because you have to be able to read for each one in the formula, how many oxygen do we have? 6. How many N do we have? 2. And how many calcium we have? 1. That is very, very important. And then the rest is very similar, just multiply and adding, make sure you keep the right number for 6 figures. Right? So do a practice. That means you have to translate this name into the right formula. Calcium phosphate. So that means your calcium phosphate Ca3 PO4 2. Good. So you make sure you put the parentheses in the right place. So first write the formula. See if you get the formula right. You have a calcium phosphate. Calcium is Ca, right? Phosphate is PO4. P and O. Subscript. So then the charge of this is 3 negative. You can put 3 negative on the top. And the charge of that is 2 plus. So then we do the switch. Let's do the practice. What do you write? What is the symbol for Ca for calcium? The Ca2 plus, right? And Ca is equal to 2A, right? Calcium is Ca, right? So just write, let's write that out first. You can write the Ca2 plus.
It's A.
Probably. So you first write the C is 2 plus, and phosphate is PO4, subscript 4, then the charge altogether is 3 negative on top. So then you switch, you have the 2 here, you switch on this as a group, then we switch on this here. Then we write PO4 in parentheses, PO4, and we have 2 here, the 2 come from here. Yeah, so that's it. You get the formula right. Very good, that's good. So you have this 3 from this, then PO4. You keep that together, don't change that, because you still have PO4 here. And put that together in the parentheses. No, put this PO4. No, see. Now you are getting 2 from this. Don't do the multiply yet, because you know this is for polyatomic ion. That is what you use this way. But we want to figure out how many codes they have in Do you get the formula right? Alright, I think you can do that. So this Ca is 2 plus, PO4 is the phosphate is 2, 4. Understand? Right? So what you do, you will take a little switch and onto this keratin. You will take a little tool onto this and the tool and put it here. So therefore you put it like this. Right, so once you switch, you don't have to write those chart anymore. And you have little people for like that. But in your mind, you still know that C is the 2 parts and Q for the 3 level. Then when you want to figure out how many O's we have, let's see how many C, we have 3 PA, that's clear, right? Okay, now how many P do we have? We have P, 2P. And how many O's do we have? So that's very important for this study. I don't know how many atoms in the formula, or I think so. That's 4. Alright, so prepare for the lab for Thursday we will lab. I think we will do this. We will do
I'll just throw that in there.
Because I didn't really see that sentence when you did it.
I just joined.
Okay. And then I was just going to staple it. Yeah, no, I just
See, the thing is, they don't want you to keep your phone anymore. They want to trade up. Yeah, they want you to get your old phone back. Which I'm not really fond of.
Yeah, you already just hold on.
I gotta ask you some questions.
Alcohol has more oil in it versus water doesn't, so I guess that was the
Oh, this one. This one.
Next week, yeah, I'll be right. Rock and roll.
You can just use, you can do everything. Yeah, I want to do everything for all those things. But only one solvent. You don't have to do the solvent you do not use. You use solvent, that's water. So you can do the water solvent for all those body things. Then you just also do the unknown. And then you can compare, like, the pain, the unknown is really what pain. So you will see you pretty much imagine the pattern, the color pattern, and those numbers will also imagine.
Should be similar.
Yeah, what we said. Yeah.
Okay. Okay, awesome, thank you.
Okay, welcome. Yeah, you can sign now. I think that you can.
Really?
Yeah.
Oh my gosh!
Yeah. Get the form, and sign that.
Thank you so much. I was freaking out. I'm so happy. Thank you. But yeah, that's the quiz. I took it over the weekend. So did he drop on his own, or did you? Give him I probably not able to something else. I think what the lady at the register's office is
I have to-
description
I signed it,
and
Cost description, just general comes to one.
then I'll swing by tomorrow and
Mhm.
give it to the register's office.
Yep.
Or maybe Thursday.
Today is 15th, right?
Alright, and I think that's it, right?
Yep, all set.
Rock and roll. Thank you so much.
Welcome.
Really glad to finally be in this class. I'm glad I wasn't all for nothing.